So we already talked about the sublevels that the electrons can go in and how many orbitals each sublevel has. And so we can put them in a chart like this, and it's kind of like we did with the Hog Hilton. On the Hog Hilton, where did we start putting our hogs?
At the very bottom.
At the very bottom, down here, because that's where it takes the least energy, and electrons are like that too. You want to start at the lowest energy and you want to move your way up. So let's look at how we actually do this. Beryllium. And if we're going to do an electron configuration, we need to know how many electrons it has. So how many electrons does beryllium have?
I look at the periodic table and I look at the atomic number, right?
Mm-hmm.
It's number 4, so he's got 4 electrons.
So beryllium has 4 electrons. And so we're going to put those kind of like we put our hogs. We start at the lowest energy level. We always put our very first electron in 1s. And we're going to draw our electrons like arrows. Electrons are always spinning and it gives them a magnetic field. And so if one's spinning one way, it's got one magnetic field. Like, say it's like the North Pole of a magnet. If one's spinning the opposite way, it's like the South Pole of a magnet. So if I've got one North Pole, what do I want to put next to it?
Something that's the opposite. So let's put an arrow down.
Right. So we're always going to put an arrow up and an arrow down. That's the Pauli exclusion principle. You've got to have opposite spins or they're all going to fly apart.
Okay, makes sense. So it balances each other out.
Mm-hmm. And so now we put our first 2 electrons. We've got 2 more electrons. Where do you think we're going to go next?
To the next blank that just steps us up, so that I guess that'd be 2s.
Right, because that's our next lowest energy. So what are we going to start with?
An arrow up.
An arrow up, and we've got to pair that with?
An arrow down.
An arrow down. So now we've got electrons in 1s and 2s, and we can actually write out what that looks like, so we don't always have to draw a bunch of arrows. So we've got 1s, and 1 is our energy level, and then s, what did we call s?
A suborbital?
Our sublevel.
Sublevel.
And then how many electrons are in our 1s?
There's an arrow up and an arrow down, so 2.
2. So then we write a little superscript that tells us how many electrons. And then we can write the same thing for our next set of electrons. So what am I going to write for the rest of my electrons?
So that would be 2s.
2.
2.
S. 2. There we go. That is our electron configuration. And then let's rewrite that down. Let's rewrite that so it looks a little prettier. 1s2, 2s2, that's our whole electron configuration. There's actually shorter ways to write that, and we'll look at those later. Let's try something that has a couple more electrons. Let's try carbon.
All right, carbon. I've seen carbon enough. I think I've got this memorized. Does carbon have 6 electrons?
Carbon has 6 electrons because that's its atomic number. So, carbon with its 6 electrons, where are the first electrons going to go?
1s.
1s, and how do I draw them?
You draw one arrow up and then an arrow down.
Arrow up, arrow down.
And then 2s, arrow up, arrow down.
So how many electrons is that taking care of?
4 of them, so we need 2 more?
We need 2 more. And then think back to Hog Hilton. Are we going to put 2 of them in the first 2p?
I think everybody likes to have their own room first.
Everyone wants to have their own room first. So we're going to do 1 up and then another 1 up. Because this is Hund's rule. It's kind of like when you're getting on a school bus with people you don't know that well. Or, you know, if you play a sport and you're all gross and sweaty after a game, everyone gets on the bus. What do?
Sit in their own seat.
They sit in their own seat. So they're going to not pair up unless they absolutely have to. Here we only have 2p. So that's where we go. All right, so we're going to write our electron configuration. What do we write?
So we'll write 1s2.
1s2, first energy level, s sublevel, 2 electrons.
Okay, 2s2.
2s2.
And then 2p, and since there's only 2 arrows, I'm going to write a little 2 up top.
There you are. And what do you notice? If you take all your little numbers of electrons and add them together, how many do we get?
Well, 2 plus 2 plus 2 is 6.
Right. So do we have the right number of electrons?
We do.
Good way to check yourself. All right, we're going to try oxygen. This is on your paper, so you should try this on your own. So take a second, try it on your own, then we'll work through.
All right, so oxygen has 6 electrons.
It has how many?
8.
It has 8 electrons. It has 6 valence electrons, and we'll get to that later. All right, so it's going to have 8 electrons because that's its atomic number. I do the same thing sometimes. All right, so where do we start?
1s.
1s because that's our lowest energy. We do arrow up, arrow down, then we go
2s, arrow up, arrow down.
All right, and what did we say we needed to do before we paired?
Everybody gets arrow up in the blank, and then you start putting arrow down.
All right, so let's start with our arrows up. We have 1, 2, 3, 1 in each of the 2p's. How many electrons do I have here?
Let's see, 1, 2, 3, 4, 6.
How many?
7.
So we've got 7 electrons. How many do we have left?
1 more.
So where am I have to put that?
put it with your first arrow that you drew for 2p.
Right. So we put one in each. So if we have one in each, we have to go back and pair. We can't go up to a new energy level until we've got 2p filled. So what's that going to make?
So we've got 1s2, 2s2, 2p, and there's 4 arrows now, so I should put a superscript 4.
And we add up all our numbers of electrons, and we get 8 electrons, which is how we know we're good. All right, here's another one that is in your packet to try. So what have we got?
Iron, a transition metal.
Okay. And so it's got how many electrons?
26.
26 electrons. Okay. And we always start
With 1s at the very
one
bottom.
S. So we've got 1 up, 1 down. And then we go to 2s, 1 up, 1 down. And then we do
2p.
2p, and we're going to start with 1 up, 1 up, 1 up. Are we out of electrons yet?
No, so we keep on going, so we got to put arrows down for all of them.
1, 2, 3, and that gets us 10 electrons so far. We haven't been this far yet. Where do we go now?
It looks like you just keep on stepping up like a stair step or ladder, so it'd be 3s.
3s, and so we have 1 up, 1 down. That gets us 12. Now where do we go?
3p.
And we still want to do 1 up in each. 2, 3. All right, how many electrons do I have total so far?
All right, so we've got 2, 4, 6, 8, 10, 12, 13, 14, 15.
Okay, so we're a little over halfway there, so let's go back and pair our 3p's.
So we've got 18 now. Let's
Okay.
go to 4s and put some more. That's 20.
Okay.
So we got 6 more we need to put.
Okay, so how do I need to put these?
It looks like 3D, and you said that we put an arrow up in every single one before we put an arrow
All right,
down.
so
we need
let's-
to put 6 arrows up.
1, 2, 3, 4, 5. Well, I've got 5 of them.
Oh, so put 1 down. Okay.
Put 1 down. There we go. So that's our 6 electrons that we had left. So now we need to write out our electron configuration. It's exactly like we've been doing. It's just longer now. All right, so let's see what we need to write. We have
1s2,
1s2,
2s2,
2s2,
2p6,
2p6,
3s2,
3s2,
3p6,
3p6,
4s2,
4s2,
and 3d6.
3d6. All right, so what did you notice we did? What do you notice about our big numbers?
It looks like they go in a really specific order, and
Did we keep filling 3 until we were done with 3?
yeah, you had to fill them all up. You put arrows in all of them before we moved on, and now it makes sense when you said that S can only hold 2, and I see that the biggest number of arrows you can put in all the blanks that have S is 2, and you said that P's could max with 6, and that's the max arrows. D would be 10, and F would be 14. That all makes sense now.
Okay. One thing we do want to notice is our 4s came before our 3d, and we'll talk about that a little bit more with our periodic table, but just know that S's are always lower energy than XD. You don't really need to worry about it. Just follow your map. Don't worry about the fact that your numbers get bigger and then smaller again. So one more we want to do real quick. So let's try this one.
Chlorine, atomic number 17, so he's got 17 electrons.
17 electrons. All right, where do we start?
1s at the bottom again.
All right, and we can put 2 electrons there, and then we go to,
The next one, 2s,
okay, 1 up, 1 down.
and then 2p.
We start with 1 up in each, and then go back and pair, and that gives us how many electrons so far?
Let's see, 2, 4, 6, 8, 10.
Okay, so we've got 7 left. Our next ones are going to go
3s.
3s, 1 up, 1 down. That gives us 12.
So then we need to work it out till we get to 17.
So let's do 1 up each in 3p. That gives us,
15.
and now we need 2 more, so we do 2 downs. And so what's our electron configuration going to look like for this?
1s2, 2s2, 2p6, 3s2, 3p5.
There we go.